everyone to an awesome panel event. We have with us tonight three exceptional speakers. We would have had a fourth, but unfortunately Damien Katz missed his airplane. Sorry guys. But we do have three remaining. So hang on for a fun ride tonight. Starting, I guess we'll go right to left. My right to audience right to left. We'll start with Geir Magnusson. He is the CTO and Senior VP of Engineering at AppNexus. He was formerly the VP of Engineering at Tengen MongoDB and has former tech exec experience at this Intel, Bloomberg, Guild Group, Choose, Vigo, and it goes on.
I can't hold the job.
Great answer. He also founded the Apache projects Geronimo, Harmony, and Velocity. We also have with us next is Proctor, the CTO of NuoDB. He has nearly 20 years of industry experience, has 8 patents, and formerly worked at both Nokia and Sun Microsystems. We also have Robert Greene, Senior Strategist for Oracle. He champions the Oracle NoSQL database project. 18 years of experience in NoSQL and object relational mapping, and prior was a VP of Tech at Versant Actian. Please welcome the three panelists. We're going to start off the session with just a brief elevator pitch of your technologies from me in that direction, if you don't mind.
Sure. Oracle NoSQL database is it's a scale-out NoSQL database, which is a elected master architecture. So you store some hardware at us, scale it out, we automatically figure out how we get you the most write throughput, the lowest read latencies, and we lay the processes out for you, and you just start writing some code against it. Seth?
Apparently NuoDB makes t-shirts and earbuds. When we're not in the branding business, we also make a web-scale distributed database. It's actually a SQL database. It's really relational, really ACID, joins, DDL, indexes, all that good stuff, which should be a relational database, but designed around a kind of fundamentally new distributed architecture that lets you do kind of on-demand scale for performance, for continuous availability, for kind of interesting multi-data center distribution cases, and increasingly kind of built-in automation and data intelligence to be able to do some pretty cool things that let you, as an operator, actually sleep at night.
And Geir, if you could kindly just...
Or do whatever it is an operator does at night.
And Geir, if you could kindly just give a background of your data-related experience, including here at AppNexus.
Sure. Yeah, I was going to say, other than being in the event business here at AppNexus, where I'm the user, I guess, on the panel, because I do have some experience on the vendor side, building, certainly my time at MongoDB, I know now, and Gems then. But here at AppNexus, we are a big user of data. You can imagine that, I guess, we use things at web scale, is the way I would put it. We, like I said, we'll see 1.5 to up to 3 million requests a second. We, all of it is important data. We log all this data. We have to process all the data. We do server-side cookie management at about 1 million writes a second. So we do some serious data usage.
Okay. This question is for Robert and Seth. What are the core principles of innovation that drove your products? How did you come up with NuoDB and Oracle NoSQL? What innovative ideas were the foundation of it?
Well, you want me to start?
Sure, go ahead.
Okay, so I think from NuoDB's point of view, you heard earlier Jim Starkey, he's our technical founder. He's been in the database industry really since there was a database industry. He was looking kind of 2005, 2006 at this increasing trend towards NoSQL and said, really great set of tools, right? Really cool technology, solves good problems. But also at the same time, kind of a lot of opinions that, well, we have to do this because SQL doesn't scale. We kind of looked at that and said, well, SQL is a declared language. Of course it can scale. And transactions, we know they can scale. Sometimes there's latency. Sometimes there are challenges on what you can do with them. We kind of said, I think people are looking at this the wrong way. We got really excited at kind of saying, how do we really step back and not try to build a slightly better system R? How do we really rethink the architectures that we want to be able to get low latency, to be able to get true transactionality across the distributed system? And I think that's kind of where that started, was that challenge he felt at saying, there's this popular perception that there's a truth about relational databases. And I think what you see today is you see a lot of I hate the term NewSQL. We see a lot of NewSQL databases out there today that are kind of pushing those same boundaries and saying SQL can scale, transactions can scale. Certainly Berkeley as well as an example, Oracle NoSQL is a great example also of technology where transactions scale. And I think that's kind of part of what's fun about where we are in the database world right now is we're kind of in this period of going through all of these kind of assumptions about truths of architecture because they've been around for 40 years and testing them. And it's fun. It's part of what we're going to talk about tonight.
And from Oracle perspective, if you could just imagine doing things that are completely different than what the conventional Oracle engineering team likes to think about when they do things. So, from a technology perspective, we certainly are looking to, I would say, sort of create a class of NoSQL technology, which is more of an enterprise-grade capability. And it's not to dismiss other technologies that are out there in the NoSQL space, because there are a lot of good technologies out there. I think it's just more of an acknowledgement that the workloads that we're seeing that drove the evolution of these technologies are real. And so, sort of what I would say, descent from within. Being inside Oracle and looking at these issues and creating the technology to help deliver on managing data under these workloads. I think that we have this culture which likes to deliver things in a very packaged format. So you see us delivering things on one scale in terms of engineered systems, where we've got these things we call big data appliances that literally have hundreds and hundreds of cores, tremendous terabytes and terabytes of memory. So we're building these NoSQL databases that can actually scale across these engineered systems. But we're doing that in such a way we can also put that in the hands of somebody who doesn't have the money to invest, that isn't one of the largest banks in the world. You can take that same technology and put it on commodity-based hardware and still get the same manageability and deployability. And so I think that's innovative in the NoSQL space. One of the places where Oracle is really trying to stand out.
Okay, just to kind of ask for the background of the databases specifically, would you call Oracle NoSQL a one-size-fits-all or a special purpose?
Well, it's definitely a special purpose platform. And I think that's the whole point of this evolution of data management technologies is an acknowledgement that you have different use cases, you have different workloads, you have different shapes to data, and it's no longer an era of one tool is the right tool for all jobs. You need to basically use the right tool for the job, and Oracle NoSQL is just one of those.
What data projects would you say would be ideal for Oracle NoSQL?
Well, I can just speak to what it's actually being used for. So, if I look out into these, you're going to hear about these in pretty much every marketing pitch and every NoSQL vendor, right? So, but in the financial space, you've got guys that are running our systems in production, managing fraud for some of these credit cards that I'm sure are in every one of your wallets. So somebody swipes a card, and the moment that they swipe that card, a transaction is going back out to pull a history of what's going on with that card and a history of other surrounding transactions and try to make some decisions about what may or may not be a fraudulent situation. And then we've got large industrial manufacturers that are making airplanes that are flying around the world. They're trying to figure out how to make those things safe. And so when they're building these things, they're outfitting them with literally tens of thousands of sensors. And all that data is flying back in off of these aircraft as they're flying around. And then the analysts are basically looking at all that data to try to understand how things are changing and being impacted over time with stress loads. So it's in situations like that. We've got a huge ingestion of data, but at the same time, you've got a fairly high concurrency access to trying to read that data while you're ingesting it at the same time. A load which isn't traditionally handled very well by relational technologies, which tend to deal with much more structured data.
Seth, same question. Is NuoDB a one-size-fits-all, or is it a special purpose? If it is special purpose, what data projects would it involve?
So I'll start by agreeing with the comment that I think part of what's great where we are right now is that there's so many great tools for different projects, right? And there's no, we already heard a little bit about kind of what goes on here. You're chatting for me, I'm sure there's like a pile of different projects here, and you need that, right? There is no one size fits all. And I think when you look at the problems that people want kind of a relational or transactional SQL system to support, NuoDB in that sense is a general purpose database, right? It's designed for small sets of data, large sets of data. It's designed for large numbers of concurrent users, smaller specific applications, kind of massive workload capability. So it's designed kind of for general purpose. It's obviously not designed for the hundreds of petabytes of big data type systems. So in that sense, that's specialized today. But I mean, it's designed to be something that can work for kind of many different use cases. In practice, we have customers, from tiny startups that are trying to figure out how to just get scaling right now on Amazon, and they'll worry later about if they get really popular, how do they set up scaling? Right up to enterprises who are saying, today I'm running on just gigantic systems, and I want a simpler way to do it.
Okay. And Geir, do you have a feature wish list for a database, anything? Like, if you could dream it up, what would the ideal database system be for you? That you don't have today, or at least you're not aware of.
Where do you start that list?
I'm very much in the camp that I was going to joke that I don't know what you're talking about, these multiple solution things. We keep everything in its old Sybase 8 database thing. I never think about it that way, actually. It's an interesting question. We think about it here as we have several different problems we have to solve. We do not try to solve them the same way, right? We use MySQL. But we do relational, and relational is very powerful. We use MySQL, we use Postgres for two different things. We use Vertica, because we do want that sort of scalable relational query capability. We use HDFS and Hadoop and Hive and all that entire ecosystem. We've got 2.5 petabytes of data that we have to deal with at any one time. And then we use very, very fast KB stores for that sort of million per second, 1.5 million per second thing I was talking about for the reason rights for the server side. So I don't think I could ever come up with, or would even want to, try to come up with the one database that serves all of this. I don't believe it exists.
Okay. Seth, we're going to try a little controversial one. Is there any feature or functionality that's in Oracle or any Oracle product with MySQL that you wish NuoDB could replicate?
Is there any feature in...
Besides the revenue.
Yes. Fair enough.
Well, so as a longtime Sun employee, I have to be very careful now not to come the immediate snarky answers that are coming to mind or like fighting my brain for the real answer. Is there any Oracle feature that I really, really wish we had today in NuoDB? They're actually, it's too early to be too controversial. I won't push too far. I will say there are actually a couple things that we are currently in the process of building. I think we take a lot of inspiration kind of from what's in Oracle today. Because when you go into an enterprise shop today, it turns out people still use SQL. It turns out things like enterprises still like Oracle RAC. And so there are capabilities that, especially at the high end, are super critical. And part of what we're excited about is not just being able to keep providing those at the high end, but be able to commoditize those so that people who are running on public cloud on just like cheap commodity systems can do things like point-in-time backup, or like data partitioning that doesn't just let you drop partitions quickly, but lets you do kind of geographic partitioning of data for really important cases, things like audit and policy, things like data management across the EU. Like, go talk to anyone in the EU and ask them what happens when a German citizen logs into their service. Because, like, that's a thing. And that's very hard to deal with in traditional systems. And so being able to take kind of spiritually what Oracle provides for a lot of those use cases and bring them to kind of more commodity, I think is really cool. And I'll hold my super snarky Oracle thoughts for personal discussion later.
A very similar question for Robert. Are there any other database platforms that you wish you could pull features from and get them into Oracle NoSQL?
Okay. Yeah, I thought you were going to ask me the Oracle database. Sorry, I'm no SQL guy. But I think to complement my colleague up here on the panel, I think NuoDB, one of the things that is bringing to the table is the fact that transactions are important. There's an emerging class of databases that are coming out in this NewSQL, NoSQL, modern data management tool paradigm, and transactions are becoming more and more important. And so it's great to see companies bringing that to light. Google, with their spanner, it's a big table, but they needed transactions, right? Twitter, with Cassandra, but they created Manhattan because they needed transactions, right? So, that's one of the things which I think is important in NoSQL technology, and I admire in what, for example, the work that Seth is doing.
Okay, and Geir, if either NuoDB or Oracle NoSQL wanted to pitch to you to get them to use their databases in AppNexus, what functionality, features, and performance would they have to sell you on so you say yes?
For us, performance is a biggie because at the scale that we are, the cost of the hardware matters. So performance is very important, but also operational stability is a biggie, right? We don't go down. We can't go down. We keep joking that the internet's going to be down for maintenance from year to year on Sunday night, but it doesn't really work that way. We have a worldwide business, and people are advertising 24/7. So that kind of operational stability where things work and we can maintain them hot, you can bring those in and out, and you can change the oil or the tires or whatever you're going to do to your server systems, which we're doing constantly. Being able to do that without a lot of stress on the operational staff and without going down is really important.
Okay, let's talk a little about the future. What big databases do you think will be still around here in 2020? That's for Geir.
What databases will be around in 2020?
Besides the new ones that might be invented by the current selection.
That's a great question. Oracle is going to be around. There's just no way that's going anywhere. Right? Relational database, you mean as a class or by vendor?
However you want.
The relational database isn't going anywhere. It's just going to get better. It's going to start adding a lot of the innovative features that are coming out of the NoSQL, NewSQL, NeoSQL, I mean, whatever we're calling this evolution of technology. I think they are going to adapt, which is, I think, a convergence of a lot of what we wanted in the early NoSQL stuff that we couldn't get from the relational. And the relational step up and start to do it. Certainly I don't see the distributed file system approach going anywhere soon because there's just no way to keep data otherwise on a massive scale. And these databases are getting bigger and bigger and bigger. KD's not going anywhere as a class. It will always need things like that. And I wish I had a deeper answer than this, but I don't see it as, I don't know what's coming. I certainly see what we have now and what's certainly useful and stable.
Great. And Seth, in the year 2020, the majority of databases you think will be relational, non-relational, or a hybrid?
No, I totally agree with almost everything. Well, totally agree actually with everything I just heard. I think that there's increasingly kind of this trend that the relational databases are not going away. They solve a really important problem. They're evolving and they're maturing, right? And like NuoDB, for example, we have a very flexible schema model that lets you just change things real time. That's really critical because NoSQL systems, I think one of the really valuable things is having a schema model that can change on the fly. You really like restructure data so you need to grow, right? Those are those kinds of things. And then we see things like NoSQL solutions that are also trending towards having transactions, having a consistency model. I mean, these things are really critical, I think. I suppose if someone could figure out how to put Cassandra on a ZOS system, like that one would outlast the heat death of the system, of the universe. But I mean, definitely, I think what the other thing that's really interesting. So you made the comment about kind of the file system, kind of the distributed file systems, right? So I mean, when you look at like the work that's being done right now, the work like Spark and Sharp, right? They're saying Hadoop kind of went through a first generation that was really cool, really powerful, right? But it's on disk. And everyone is moving towards being able to do things in memory. What does it look like when we hoist that into memory? And then you take kind of those things and you look at like what they're doing against, say, like Splice or something, right? You're saying, so if we hoist things into memory, and we understand something about, a declarative language that we can reason about, what does that give us in terms of really interesting query capabilities? Where does that intersect kind of what you want to do analytically with kind of some kind of consistency model? So it really is kind of this intersection both of, it's not really about SQL or NoSQL, it's not about transactions or not transactions, right? It's kind of these databases that are maturing and are kind of understanding how to merge these different problems together, and also understanding, importantly, architecturally what changes, right? Why is it important to be in memory? Why is it important to be able to take advantage of networks in some cases, but really be able to get ahead of network failures in other cases? Why is it important that Amazon is just like the best test case ever for a distributed system person, because things fail there worse than like anywhere I've ever done work, right? I mean, it's awesome. It saved me so much effort in like constructing test cases, because I just like twisting my hands. I'm like, oh, look at that. Broke it away. I never would have thought to test. You know, so it's like, it's like chaos monkey doesn't need to exist. It's like Amazon just doesn't. Sorry, if anyone's in the room and if you fiercely love Amazon, it's fun to. So, you know, I think that's kind of, again, that's part of what's fun about this new generation of systems we're working on, right? Is we kind of get to step back and say, let's take the 40 years of experience, let's understand what the real problems are that people are looking at for the next more than 10 years, right? The next 20 years, 30 years, and then how do we kind of like roll that all in? So, I mean, I think that's kind of what we're talking about, and that's where we're going.
Yeah, and there's two interesting things. Like, you talked about memory versus disk, but in 2020, do you think, like, I think that memory and disk are also converging, right? Because I'm starting to see, you know, solid-state systems that they're still not memory speed, right? But they're starting to...
They're awfully close.
They're awfully close, and they're doing things like plugging right into the DRAM slots, right? So it used to be you put it into PCI, and then... But now you're going right into RAM slots, and we spend a lot of time thinking about how we can do faster systems here. So we look at anything from SPI.
Yeah, maybe by 2020 we're all in business because like quantum computers that finally come through.
Yeah, or just that memory is stateful. It doesn't need to be refreshed constantly.
Yeah, I actually think that that's right. I mean, you look far enough out, and these things come in cycles, right? And even virtualization, all that, if you're old enough, you know, you can think back to the mainframe era and see that a lot of this stuff existed there, right? And you know, so commodity hardware, you know, what is commodity hardware blocks, man? They are getting so freaking powerful, right? I mean, was it my cell phone is more powerful than the computers that sent the first spaceships, you know, to the moon, right? So
you use it to play Angry Birds.
Yeah. You know, so in 2020, you know, we may find out that the biggest cluster anybody needs is 3 nodes, and the only reason you need 3 nodes is because you want that reliability factor, but otherwise you can get everything you want, right? It's just things are moving at a voracious pace.
And on that note, in 2020, Oracle MySQL, Oracle NoSQL, what do you think is going to be the dominant of the 3 databases?
Well, I mean, it's really hard to say that 2020 because, you know, I see a convergence of these things. You know, not to say that there's one size fits all, but I don't think the interesting applications won't just need one of these things, right? So it's just hard for me to say. There's a whole lot of simple stuff that goes on out there that could just as well use a simple MySQL database, and I think that'll be around probably in a dominant form, you know, that kind of relational technology into 2020.
Okay.
That's not necessarily interesting.
And a lot of things don't need to scale.
Hey, Geir.
Crazy talk.
Geir, to compete as a database in this current year of 2014, what do you think are the key requirements?
Compete as a database in 2014?
In your decision, because you have a decision-making process to choose databases or platforms for data storage regularly, I would imagine.
Right. So for us, we are a maturing business, so we're not, you know, we have customers and revenue, and design patterns change slowly rather than rapidly. So, you know, we recently got, it sounds really boring, but for archiving, we've got an appliance now that has an S3 interface to it. You can use that instead of the standard NFS thing you would do, and yucky that way. We just would do it in an S3 API model, and it does, you know, gigs and gigs per second. It is really, really fast in and out. And I'm going to use it. It was meant as a storage appliance, and I'm going to use it as a read-write store, right, for an application. So for us, it's the ability to move large amounts of data very fast. It's one of the things that we need. We can move it in blobs and chunks, or we can also do it on a single record. We have both use cases that we need. I haven't seen a solution that does both. Right? So the problem is we keep coming up with finer and finer problems that require some serious scale and performance. So we really have to go to very specific point solutions that fit in the architecture that we're building. So maybe the answer to the question is things that are very specific and very good at one thing is something we really like. When we find products that are built for a general set of purposes, we find that a lot of the feature cruft that gets put in isn't good for our use case. For example, we have our KB store used to bias writes over reads because you know you need to keep your data safe, right? So we'd be trying to do activity on this thing, and it would be polling to get the writes done, and we would time out and hit it again to overload it. But in our business, it's okay if we miss a write because, for example, we do frequency capping for ads. Right? If you miss a write and overwrite, it means that you might see one extra ad. It's not the end of the world for us, but the fact that our systems didn't start timing out. So it's this kind of thing tailored for the scale that we're at is what we're doing.
Okay. Robert, you were formerly the VP of Technology at Sun. Some months ago, we had one of the directors speak at our group. I'm just curious, for Sun versus Oracle NoSQL or Oracle products as a suite as for Sun has multiple databases, how would you compare the two? And when would you use the one that you're not currently at?
Sure. So in some ways it's a good and yet it's an unfortunate thing that it's not just about technology, it's also about people. And sometimes it takes it takes a real maybe a genuine need, an immediate need for adoption really to cause an effect and change. And so when I was doing University, for those of you who don't know, I was in the object database business. And in many ways, object databases really are extremely advanced key value stores. One might even say they were just a little bit ahead of their time. And quite frankly, when I look at what's going on in the key value space, and I look at what some of the NoSQL vendors are doing, and they're starting to introduce into their data models the notion of collection types in their language space, that natively map to the language collections, and so that they're introducing reference types. I'm sure you're familiar with the ref type in MongoDB, so that all of a sudden it's not just a key and a value, but inside that value become references to other values, and you get this sort of networked, instead of hierarchical data models, you start to get network data models. Which brings you back to an object database. So, where this goes in the future, I think, is really going to depend upon, the real need and, in some respects, the emotional maturity of the developer community and what they feel they really, is going to be a lasting technology for them. So the technologies are really all coming, I think, in some ways, back around to where they started. That's an indirect answer, but the two are very closely aligned.
I thought you were going to get grumpy there. Have you ever heard a small talker talk about Java? We had this back in the object database days. There's nothing new here.
A little of that. Right? That's exactly what it's like.
Okay, so
Sorry, wait, is this no small talk? Because no one's laughing.
No.
Here we go.
All right, there's another question. Does anybody know Java? Okay. So that old.
Okay, and Seth, we're going to try Seth, we'll try a similar question with you. You work at Sun Microsystems. NuoDB versus MySQL. Is there ever a case where you choose MySQL over NuoDB?
So right off the bat, I'm just going to say it. I was at Sun Microsystems for a very long time. A lot of us were not super crazy about Jonathan Schwartz. It was not just the ponytail. It was kind of several decisions, although the ponytail didn't help. And I think when he decided to shell out $1 billion for MySQL, a lot of us kind of thought he'd finally gone off the deep end. So I'm the wrong person to ask this question because I have too much emotion tied up in this one. MySQL is obviously an awesome technology, right, that has come a really, really long way in a short time, right? I mean, for those of you who remember what MySQL looked like 10 years ago, transactions were a novelty, right? I mean, this was not a transactional, optional, and amazing. I mean, technically, you go back and look at Oracle version 1, there also weren't transactions, right? So I mean, things grow, but I mean, Oracle had 35 years to do it. MySQL had a very short window of time to do it, and it was all community. And it's kind of amazing what it's done, And when you look at 5 years ago, kind of the chaos around what the different storage engines were in MySQL, it's pretty amazing.
So respect checking strings.
Well, look, I'm trying to be nice, right? I'm trying to. So I mean, it's an awesome piece of technology, right? And it's a real enabler for people. I mean, I think you asked a little bit of a loaded question. So now I'll put on my snarky hat a little bit and just say that I think kind of one of the things that's unfortunate right now is what has happened with the MySQL in kind of because I think that's been its strength, right? It's the technology, but it's also the people involved in it. And you know, unfortunately, right now, what we see is a community that's really having kind of a, you know, an emotional of spiritual crisis. You know, I went through the same way. It was like, you know, long after Open Solaris was no longer open, and I was still running on my system and trying desperately to keep up with the latest hardware. My friends were all laughing at me. And, you know, I was a small talk guy, being like, "You guys don't even know what operating system lightweight processes and other things are. You don't have it so good."
E-trace, I'll show you E-trace.
Yeah, well, wait, sorry. I realize I got on a rant there, and I apologize, but I just do want to say, so in terms of technology, and I think MySQL is an amazing technology, right? I think today, honestly, you know, I mean, I think it solves a great set of problems. Part of why I'm working on NuoDB is because there are another set of problems that are very hard to solve. And I think that's just kind of the reality, is that when you start thinking about, you know, I want to run 15 instances and do multi-master replication and try to keep things in sync and try to understand kind of, you know, how I don't have to shard and what happens in failure cases. Yeah, I mean, it's just never designed to do those things, right? So it's great at doing certain technologies. It's kind of, you know, there's very little that I look at it today and say, I wish I could cherry pick thing X and bring it into what I do today.
Can I touch on that? Because you said something about the crisis of the community. To me, our business depends on MySQL in the form of community.
Right.
And we feel that that's a perfectly fine shape. So I might not have been paying attention lately, but is that what you meant? Or
No, sorry. So to be clear, Maria to me is a separate community. I have a lot of friends who are there, right? And so when I hear MySQL and Oracle in the same sentence, I think of MySQL,
right, that's
not Maria. You know, Drizzle is another community that kind of is obviously not MySQL, but kind of has come from a lot of the same, you know, the same lineage, and there's a lot of great stuff, you know, going on. I mean, I think Maria is a place where there's a lot of great activity. And I think the interesting thing about what's happened is that while I think the Oracle MySQL people, you know, are kind of very nervous, what that has done is has prompted a lot of growth in communities like Postgres, which I feel kind of was not kind of rocking the way it should have been lately. And when you like, who's the open source kind of thought leader doing things like, you know, how do you pull JSON into a relational model? I think it's Postgres that was pulling from. You know, so I think there's a lot of, you know, all these things are cyclical, right? So you see great like growth coming into these things because they're kind of taking away from other places. So yeah, not like Maria's love the seal.
Okay. And Gary, you've worked at Tension at MongoDB, so we're going to ask a similar question. Is Mongo used in the AppNexus stack? If yes, why? No, why not?
It's not.
It's not, why not?
We don't have a use case for it, to be honest. Look, I am actually a big fan of relational databases when a relational database can handle what you want it to do. I actually argue with developers when they say, but think of the agility I have in changing the document format on every accidental release of my code. It's not what you want to do. Right? No, I mean, seriously. So we've had this debate for one use case, and it turned out that it was, you know, look, Mongo does amazing things, right? It's just not the amazing things that we needed to do. They wanted to use it for what I think is the most attractive feature of MongoDB is that out of the box, you turn it on, and for a lot of languages people are building web in like Node and whatever, it just works, and it works really well. But we didn't need a new technology. We had existing technology. We didn't have to have our operations staff learn something new, and we didn't, you know, we just didn't need it. So that's really the reason.
What is your data stack?
Data stack. So like I said, we use MySQL MariaDB for our main business object. If you think of what must happen in an advertising auction, you've got our members in the exchange, and they've got campaigns and creatives and targeting models, all that kind of stuff. That's MySQL. We also use Postgres because I'm more of a Postgres fan than a MySQL fan, so anything new is going into Postgres. We do HDFS, I do Hive as the stack for our big data stuff. That does tags that get pushed into Vertica. We've got some large Vertica clusters, each about a half petabyte, that we use for reporting and analytics and those kind of things. Like I said, we do the Aerospike is what we use for our KV store, and that's, you know, I get the million writes a second, 2.5 million reads a second. Clusters range for Aerospike from 10 to 15 machines. We do fairly beefy, dense machines. That's, I think, every everything. We used to have Netezas. That actually created Hadoop, but the Netezas hit a wall, so they rushed and got the Hadoop in place. The Netezas are slowly being cycled out. I think that's it. Plus I'm sorry I don't remember the name of the vendor. It's a multi-petabyte thing with an S3 interface that is just looks like a bat out of hell. Which I would love to talk more about it. We just got it and are using it. I forget the name of it. So, I'll see if I can remember before.
It's no secret that Oracle's acquired Sun Microsystems, which included MySQL. So what will it take for Oracle to decide to acquire NuoDB? Throw a left field question out there.
You make that out to Seth Proctor.
What value would they have to bring to Oracle?
What you're asking?
Yeah, well, certainly, of course.
Well,
Does Larry allow this?
That seems like an odd question, but I guess not in that, you're talking about a SQL database and possibly being, because of its design, somehow different and perhaps more suited to ongoing concerns who need a SQL database. Quite frankly, it would take customers. It would take a user base that came back to Oracle and said, this is delivering something for me that you can't deliver for me, and I don't see you getting there in a meaningful time frame. And so then, if it gets to that, I don't think money would be a problem. But of course, we're going to play it like that then, aren't we? Yeah, if there's a demonstrated need, there's a demonstrated community out there, then that makes things interesting. Bigger companies. I think that's the bet that VCs place on these things when they incubate.
Okay. Seth, if you were to build NuoDB from scratch today, what would you do differently?
Would you build it in Node?
Actually, that's actually a good question. What language would you
Totally built in small town. We could fill another hour here, I think. Everyone in this room has done a large system at least once in their life where they, 2 or 3 years later, they can look back and say, all the things that you do that differently. I think a couple things I would do differently, personally. So the NuoDB actually we use several languages in our stack. The core database is written in C++. We have kind of a management administration provisioning tier that's mostly written in Java. Sitting on top of that, we have tools written in Python. We have things written in Express. We're increasingly kind of pulling in other languages. And yes, we do things in Node. And yes, we do things in whatever. No, I would not rewrite it all in Node. I have a great love for Node, but seriously. But I think I probably would look at rewriting that core in a different language. I think C++ has a lot of advantages when you're really worrying about kind of screaming on a single system. I think where NuoDB shines, where its value proposition is a very different, to your point, right? It's a very different set of value propositions than what traditional relational databases are. It's about running in multiple places. And that's not really about kind of screaming on an individual processor or very fast on a single processor. It's really about being able to handle a lot of, modern. Usually my strong bias as a former Sun person is always to say Java when that question comes up. A few months ago, I finally decided that it was high time. I was far enough behind the curve that the curve was going to come back around again for like the 4th time, and it was time to finally sit down and learn Erlang. I have to say I'm kind of a fan. I don't know how much of our core system we could do. NuoDB is a pretty complicated system that's hard. There are a lot of interesting ideas there. I think probably the answers would be a combination of couple of languages. So we actually support, for example, stored procedures today that you can write in pure Java. And that really opened a lot of people's eyes. What happens when you have a distributed scale-out system where you can do Java embedded in a database? You kind of have mixed languages now. You can also do Scala if you want to be able to do that. Essentially, it's a trigger stored procedure. And then you can call out to external services from that. So it's a really interesting ecosystem of things. So I'm not sure I even come at it anymore from the point of view of a language as much as kind of how do you make a composable system that solves the right
Oracle did this like
stack.
15 years ago or 12 years ago, right? There's JVM in the database. It's interesting to see how it's going around. But I'll tell you, as a user, single node performance actually matters to us.
Oh yeah.
Right? Because we do these clusters. We've had Aerospike up to a 44 node cluster. and it just gets too expensive to manage. So we want to have the smallest number of nodes for the same performance profile.
Yeah, you can go onto the YouTubes, and I did a video with folks at Google just before they put GCE into public production, right? They gave us like 100 machines and said, what can you do? Right? We did a public test with them. We're like, well, here's a 32 node cluster pumping through 2 million transactions a second, right? And that's commodity, and that's pretty small. So like, yeah, we totally agree that like single node performance is wicked important. By the way, there you go, New Yorkers. Boston guy is wicked. You're welcome. Yeah, no. So I mean, I'm not saying like you don't want to eke out the latest performance. I'm just saying that like trying to micro optimize every last cycle when you're talking about running across a dozen machines is not the right it's not the right performance optimization to start with.
Okay, Robert, similar question. What languages are NoSQL written in, and what would you do different if you're building today?
So it's a 100% Java implementation, and I have to say, I don't know that we would use a different language, and we're quite happy with it. It presents challenges in integrating native clients that could access that infrastructure, but the fact that we can have it completely under our control, so we can have a 300 node cluster, for example, and we want to upgrade from version 2 to version 3. I mean, it's literally 2 lines in the CLI, and that's it. And things just start rolling back and forth, and nothing ever goes down. It just basically sits there and shakes itself for about 15 minutes, and then it's in version 3. And that's hard to do, in many of the other languages that I'm aware of. So I wouldn't second guess that, quite frankly. I love the client-side stuff. Coming out with much richer language capabilities on the client side, because each of those client libraries has, much like databases, they have unique characteristics that lend themselves to solving application business logic type challenges in a different way. And we look outside the web space, and we have JavaScript and all that stuff in the web space, but Python and Ruby and languages like that, and some other languages that are emerging like Go, which I don't think we've yet grasped the impact that, for example, that language will have on us. Those are interesting, and so getting those to interface with the systems design, which is rock solid around something like Java, I think, to me that's sort of.
Yeah, and for those of you who haven't played with this technology, go check it out. The core underlying thing is this thing called Berkeley DB, and it was where all this started. And Berkeley actually was originally written in C, and then there was kind of this natural evolution of like this was not solving kind of a lot of the right problems. There was kind of that natural push of like, well, Java's not going to be fast enough. Collector's going to be an issue, yada yada yada. The group of rebels said we're going to do it anyways in Java, and it turns out it was really fast. It was really good, and right.
It does work really. I've used it extensively in Angular. I use it in Guild Group as part of building more clusters. And like Berkeley DB Java Edition was one of those technologies that you use and realize that you were anywhere near the level of programmers and people that built that software. It was that good.
And it's a cool technology, and it's a great example of like realizing that core language does make a difference. Got up into Java and it really like improved a lot of things in terms of what you could do with the core system. We implement a lot of the same things in C++ and NuoDB, and you're right. It's harder. You get it right. It's satisfying. It makes you happy. But then when you're an old curmudgeonly Sun guy, you sit around drinking beer at night going, "What have we done in Java?" We're down small talk. Unfortunately, I don't even know.
The nice thing about it too is that these technologies, they are the hardest things in the world to design and build. So you meet a database kernel engineer in a corner somewhere, give them a salute, because it's tough stuff. I mean, there's a reason why you look out there across the globe, some major, arguably superpowers out there, don't have an Oracle database company that's just, delivering its in-country database, that's the equivalent to Oracle. I mean, they're just really hard to build. So Berkeley DB is a core for us. I mean, it's a NoSQL database, right? It pretty much is at its core what a lot of people are designing in these basic distributed key value stores. It simply works in a single node. And so all the cleaning activities and all that stuff that have to go on in the background processes to keep, latency spikes from occurring, to keep tight SLAs. And it took a long time to get that right. And you guys see that in the news now and some of the other technologies. I don't want to name names, but you know that some of the other popular vendors out there struggle in these areas. It's like it's fast when it's fast, and then when it's not, you don't know why. And that's a maturity thing. It just takes time. It takes engineering. It takes hardcore analysis to kind of get down and take things to that next level. So we're really lucky that we basically get to leverage that and then build out the awesome distribution and data center stuff and all that on top of it. Like Amazon and LinkedIn and Amazon.
And Geir, rebuilding AppNexus from scratch tomorrow. How would you do it?
Small talk.
Small talk. No, or Erlang, because there's like 10 developers you can hire, which keeps your team small. It's a really good question. Look, it's our main stack is in C, and I'm honestly not a fan of it because it is brittle. Right? I'm used to Java, where I have a chance in hell of stopping something going wrong because I can do things like stop my class loader, bring it back in. There's lots of things you can do. But we also need incredibly fast performance and very efficient memory usage, which is something you struggle with in Java, to be frank. Now, it's not the GC problem, that's manageable. It's just using memory as efficiently as possible. So if I was going to rewrite it now, it would be a toss-up between C++ and Java. I'm a huge Java fan. But if we can get, we really worry about cost of goods sold, COGS, or how many servers we need to do a given unit of workload. I would stay there. I'm satisfied with what we're doing in the data stack. I would not have gone with MySQL, honestly. I would have gone with Postgres. And we have PHP as our main API, and I struggle with that one too, quite honestly. I probably would have taken a different approach. Because it started out as a platform company with no UI. The idea was that we would have this exchange. You could hit it with APIs to do whatever you needed to do. And they built that very quickly in PHP. And I would have probably taken a different approach. I've done APIs in companies, so I've had the advantage of knowledge and foresight. But otherwise, it's an amazing system, and I have to give a lot of credit to the people that came before me. They did a great job.
Seth, benefits of open versus closed source for data.
I don't think you even had to add the for a database part, right? I mean, benefits of open versus closed source. I think probably most people in this room are going to understand the right answers to that. I mean, probably don't have to say much, right? I mean, open source is great. It gives you a lot of visibility. It means you have a lot of community people piling on. It also means you think you have a lot of visibility and a lot of people piling on, and so that's sometimes a crutch that you take the wrong path. I'm personally a huge fan of open source development in general. I think it makes the development team kind of much more productive, agile. I think customers tend to be very happy, with the ability to get insight into it. I think there's still, a challenge when you go into enterprise markets today, right? That when you talk to people who really consider themselves kind of traditional enterprise shops, open source is often a negative when you go sell into them. And I think that's an evolution. Again, I think that's changing. But I certainly, in the last month, I talked to 3 different customers who basically said, we're glad you haven't gone completely open source. And sitting there in the background thinking, well, that makes you, but not me. So I mean, I think what we do at NuoDB, for example, we try to walk up the line with that. So we do almost everything in terms of client side, the management stuff, the drivers, the APIs, kind of all the tools, the migration stuff, like all the stuff that we think users have an immediate need to really dig into and understand on the client side. Would the average person, even if we open sourced our software, be able to dig in and understand what our internal object coordination protocols are doing, and what the internals of a massive, multi-year distributed system like this looks like? There's not going to be a lot of insight there, but does it help our users to be able to look at, the Python driver and understand, why it is something is working the way it is, or a migration tool in a particular data type is not being pulled correctly out of the workload environment to NuoDB, for sure. So that stuff is super critical. So I think in the database context, maybe what's different there is just having kind of that first layer of things that's going to be most immediately important to users to get their jobs done is particularly important.
Robert, same question. Open source versus closed source, benefits of each?
Yeah, frankly, I think as we move forward, you're going to continue to see code being released in open source. And I think even within Oracle, I'm new to Oracle. I've only been with the company for about a year. But I can tell you that there's a lot of changes that are happening in order to move further and further towards open source code releases. We're NoSQL database is 100% open source. You can see every line of code. But I do agree with what Seth was saying, which is that it becomes particularly useful on the client side. There's this, as I just said, it's really hard to build this stuff. And we all have day jobs, and we need to actually get real product out that works, and there's somebody paying us to deliver, and we've got timelines. We can't all be database experts. And I've run an open source database company before I came to Oracle. I ran DB4 Objects, which is a 100% open source database. And you don't get that many contributions into the core kernel. I mean, it's just very rare. I think even with MySQL, you ended up with a core group of people that really were the heart and soul of the technology. And the only exception to that was, early on when you got a couple of major companies that had like, okay, we're using this stuff, and if it goes down, we're in trouble. And so let's get 3 guys on that, and become committers. And so you do build sort of an ecosystem around that, but it's a limited set of participation. It's not like you get 200 people contributing to that part of the code base. So I think the client stuff is what's most important.
Here, to shard or not to shard?
Well, I have a perspective on the open source thing.
Oh, go for it.
Right? Done some open source stuff previous lives. As a user, yeah. So in our case, we're special because we do have some people that can go into your database code and fix things. We have a few people because we work at that level in some areas. But the most important thing is there's a sense of safety. Right? If you look at the MySQL story, right? If MySQL wasn't open source, we wouldn't have MariaDB. We wouldn't have an alternative, sort of viable commercial vendor that customers could move to in the event something went wrong, in their opinion, with the original code base. Right? This is not an Oracle center or anything, but you can see this is actually what happened. The ecosystem, the customer base decided that this was a good thing, and it actually happened. So I think that's the safety net that you have. Like, nobody really wants to go into the guts of MongoDB and work on it, right? Because Mongo's doing a good job of that. But in the event something happens to that company, and you built your infrastructure and how much your petabytes of storage or whatever is on this thing, you have a fighting chance of living in case something happens to the companies.
It's interesting you actually said that, because roughly around the time when you were at Tension,
We open sourced it.
Pardon?
We open sourced it.
No, it was open source. I had a problem on a MongoDB related project that was an obscure problem, but it was a real bug in Mongo, and someone on my team patched Mongo to fix it. So they did go into the code and did exactly the thing. So
It is useful.
but I don't imagine that most teams have people capable of patching it.
No, they don't. And that's still okay, right? Just because there's people in the world that could, so. Shard or not to shard, it depends on your problem. I can go deeper, but,
Fair enough.
that's the problem.
Okay. Seth, shard or not to shard?
Kind of our whole architecture is built around the idea that you do not have to shard. It's a single logical database whether it's running on one machine or 100 machines. I have gone through the exercise of trying to build very large private clouds for a particular very large Finnish company, and the exercise of trying to shard is just not something I would want to do again.
Are you infinitely scalable? Look, the reason why I'm asking this question is because...
No, of course not. It's a trick question.
No, it's not a trick question because we have a vendor of one of our technologies that suggests that we can just keep going. But eventually you get the node crosstalk, right? There's inter-node communication that gets you overwhelmed. So we would want to partition in the way or shard.
Right. So I mean, without going into great detail, which I'm happy to do after the talk for anyone who's curious, but that's exactly right. I mean, that is one of the kind of one of those core issues that really when I mentioned Jim was fascinated by kind of where are the challenges. And so part of what he understood was in order to make a system like this scale, you can't just kind of have n-squared communication happening as you add nodes. Like there's got to be some theory about why communication is still limited, whether it's completely localized to a process or it's limited to a small subset of processes. You can't make a system like this scale if that doesn't happen.
Yeah, on my side, it's as and when absolutely necessary. Right? So we design first to scale vertically, and when that runs out of room, we like to shard. I think we'll see things cycle around. Hardware is getting so good. Frankly, the network is the bottleneck for us already. So sharding is limited in its days, but right now extremely useful for a lot of people.
Okay. And Robert, people all the time ask like what database should they choose on a brand new project, and they don't really know the requirements. What do you think are the most significant facets for them to consider in selecting a database?
They have to go figure out their requirements.
Yeah, figure out their requirements.
I mean, that's
a general question.
Yeah, I mean that's just really hard to characterize. I mean, there are certain things which I would go back to what everybody probably reads about on popular blogs, right? I mean, you've got three primary workloads. You've got high ingest, low latency read workloads. You've got sort of a bunch of unstructured data, and I need to figure out what's in it and transform it workloads. And then you've got I know this data really well, and I'm trying to do some interesting things with it from a query perspective that don't lend itself very well to a simplified data model. And so you have to look at the application you're trying to build, and you may find that you actually have, as an AppNexus case, you've got all these requirements, and so then you need to go out into each of those spaces and find one that's going to solve each of those problems. And I think what's interesting is I think a lot of people are realizing this, and the whole manageability issue that Geir was talking about is really coming to the forefront. And so if you're lucky enough to find technologies that work very well together, and can fulfill all these needs, but yet are somehow dedicated to their purpose and not creeping in features that don't really work, then you found a winner.
Seth?
Short answer, use NuoDB. The long answer is I think there are at least two real challenges that people face today, right? One is there's this amazing rich set of tools out there, and they all kind of do slightly different things. And yes, you absolutely pick the right tools for the right job, but sometimes it's really hard to understand that, right? So I think to Robert's point, right, like start out, really make sure you nail your requirements, understand, what is it that you're really trying to do, not just short term, but also longer term, and really make sure that you understand not just it's not just about data rates, it's about that network, it's about what you care about in terms of availability, it's about how you're going to operate that. I think that's the second important issue, right? Is that increasingly, right? It's not just that you've got your DevOps now, whatever your latest buzzword is, right? The reality is that when you think about the total cost of a database, right, start to finish, and you think about kind of what it takes to actually pick the right technology. Increasingly, it's super important to think about what the operations model will be, what the support model will be, what the upgrade model is going to look like, how do you keep something running forever, and that's going to have an impact. Often when you're choosing things, you're saying we're making things easier for the developer, we're making things easier for the operator. And so, there's kind of that temptation to say, well, let's pick a technology that just solves my database problem, and we'll kick it over the wall, and hope that the operator can figure out what to do with it. But they're going to turn around and be like, well, I added twice as many nodes, good luck. How to do well with it. So I think that's the other thing is seriously right up front, think very hard about what the 3-year cost will be, what the operational footprint is going to be of the technology, and really make sure you feel comfortable kind of with that part of the story as well as just what does the API look like, what does the SSC model look like.
I agree with all of this. The thing I would add is be skeptical and really conservative about using vendor-specific features, right? So you may find that a KB is what you need, or a relational is what you need, or distributed Hadoop thing. Be very careful about getting locked in by one-off features that a platform provides, right? I've done it. Everybody has done it. Maybe not done this, right? But you get yourself into a case where the best of intentions are you get stuck and can't scale out or have a big rewrite problem because there's we did an acquisition in my last company that depended upon Redis, right? Which is they really love the atomic functions of Redis. You could say add this, add this, add this, and because it was done inside Redis, it worked really, really well for their use case until they got to a volume where one node could handle, right? So they were addicted to this feature that was from a single vendor, and it was very difficult to get out of this problem because the entire design depended on this thing.
Our 3 panelists are from 3 separate geographic regions in America. We have California, we have the Boston region, and Cambridge, and we have New York. So my question is, if someone was getting into data technologies and they wanted to work in it as a profession, what geographic location would be ideal for them? Valley, Alley, Boston, or somewhere else?
As a vendor,
As a developer, as a techie, as a data technologist.
So I'm gonna,
Where's the hot region?
So I'm going to offer my view on this, having watched kind of from all three markets for a while. I think there are distinct cultures out there, right? And I think in Boston you see a lot of the kind of the core, a lot of the core early work that was happening at MIT, at kind of a lot of the universities, a lot of the original kind of industrial research labs. So you see a lot of work. You see things like NuoDB, like Folds. Interesting new architectures, interesting new architectural problems to databases. I think if you want to get into kind of the guts of kind of how these new systems evolve, I think a lot of that theory happens there. I think that if you really want to understand kind of a very practical kind of like how do I build out the next generation web environment, a friend of mine, Julia at Parse, probably a lot of you guys know Parse, has done some just like awesome stuff, and that's like classic or that West Coast mentality of like, how do I take these database technologies, how do I build wicked useful stuff on top of it, how do I kind of grow and evolve, and as a result become a database expert, kind of almost not on purpose, but like because it has to happen. And I think New York is kind of increasingly, and you can sanity check me on this one because maybe my Boston bias is unfair when I talk about New York, but go Sox. But I kind of feel like, not to alienate the entire room, I kind of feel like New York is this interesting blend between them, where there's like, it's kind of that theory and practice. It's like kind of a lot of that, how do we build the databases, but a little bit more pragmatically, like how do we build the databases that are solving kind of much more immediate problems, and then how do we use those to apply to really interesting problems that actually kind of improve people's lives.
And I would just want to say, never discount quality of life. It's a live, not just work.
Here you follow.
And obviously there are a number of cutting-edge database technology vendors that are out there. We're hiring.
Yeah, we're follow up that one. We're technically are. Come on, follow
Yeah,
up.
so the follow up, I love New York, but I would move to San Francisco in about a second. I think there's a lot of interesting things happening when you get to web scale, like real web scale. Like I think, like Google and Twitter are just amazing. The amount of data we're dealing with, right? But they're not the only two companies. And I think that if we're just going to do more with data, right? This trend will not stop. So there's a lot of interesting things that happen on the small scale, and that's actually a very valuable skill set to have, is to be able to put together an application that uses a relational database or MongoDB or whatever. But I think if you're interested in the big scale, go find someplace big that's still innovating. And I think that's where the future's going, because the amount of data we're generating increases.
I believe all three of you guys are hired, so the question would be, people who are looking to work in data tech at their companies, what qualities would the techie type need to be someone who you guys would hire here, or NoDB in AppNexus?
Start by, passionate and obviously wicked smart. I mean, we put people through the paces and make sure that they understand the fundamentals more than anything, fundamentals and creativity. But if they don't have, passion, that somehow that excitement doesn't come through in earnest in the interview process, then that takes a lot of the steam out of the whole process.
Particularly tech skills, though.
So on the database side, if it was my team, then again it means Java skills and concurrency, in particular concurrency, a good grasp of threading, a good grasp of concurrency control, and data structures, right, is a must. If I look outside, some of the other areas in Oracle, well then it would probably be C, right? So the same basic core requirements in terms of data structures and threading and all that, but through a different language mechanism. But still very, very Java focused, in particular for server-side database stuff.
Yeah, I mean, a lot of the same things. I think you use the word creativity. I think that's really important, right? I mean, all three of us are talking about kind of how we try to attack problems in maybe not exactly the same way that we used to doing it, right? I mean, databases are really exciting places to do it. amazingly exciting places to work in right now. Because like 6 years ago, people were like databases, and it's not very interesting, right? I mean, they're a really exciting place to work right now. You kind of got to check all your assumptions at the door when you enter, and you've got to really be willing to kind of be pushed and think about things in very different ways. And I think that's what makes it fun. But certainly, yeah, we're looking for obviously smart and excited people, and people who have a lot of passion, and who have a lot of creativity for these problems. And same kind of way, I've already talked about, right? We're looking for people kind of from very deep down in the stacks, plus kind of core distributed computing problems and data management problems kind of up the stack. Kind of SQL people who understand alternate languages, not just SQL, people who understand kind of alternate programming models. We're looking for people who are Java programmers, who are consistency experts, we're looking for people who are experts on Python, who are experts in scripting languages, web interfaces. We're looking for kind of DevOps people who are interested in kind of doing more of that development and kind of taking their experience and bringing it to products, because we kind of got a whole formal provisioning and management tier in the system. We're really looking to build out kind of the experience there from real world kind of practical management. People who are used to working in Amazon and Azure and Google, there probably are now starting to be a few people who know how to work in software. There doesn't seem to be a lot of love for Boston on this panel, but Boston's also great quality of life. You're right, you have to think about quality of life. We've got stuff.
There's stuff. I've been to Boston. I've been invested in stuff.
That's our new.
They have a baseball.
I think both of us neglected to say cloud. That was definitely.
I did not, in fact, neglect to say cloud.
We actually have a cloud business. We started out in really weird history. Look, we're not going to look for uninteresting people that aren't smart. Just to clear it up, we have to say this. I think what will be different is that we're looking at it. This is people who use an Anchor. I'm doing everything I can to not build a database, so I do not want to build a database. We keep sometimes coming very close to this decision. But we have people that go all the way up the stack. We've got people that really think at the instruction scheduling level in the ad server team. There's some of the most low-level people I've had to deal with in years. But all the way through people who do the distributed stuff and around Cookie Monster, it's the name of our store. Java and other languages throughout the data stack. People who understand data models. That's a really important thing for us, is people to see how all the databases fit together. You can just imagine pretty much anything you could imagine that we could need and use, we would.
Okay. And final thoughts and takeaways. We're going to start with Geir.
What would be final thought? Look, thanks for coming, right? Thanks for having me, because it was fun to do this. I think it's just keep your head up and pay attention. And I know I don't follow this rule a lot, that I will get heads down in my work, and I will miss what's happening in the world today. And there's an awful lot of interesting things happening. It's almost clearly a rebirth of, I don't know if it even is the second age, maybe a third age of database technology. But as an application builder, as a systems developer, you have more choices now than you obviously ever had. And there's some really good alternatives out there to the standard approach to building.
Be open-minded. Like, seriously, there's amazing technology out there right now. We've got someone up here who represents kind of the NoSQL point of view, someone who represents the SQL point of view, someone who represents kind of experience using lots of technologies. There is no one right answer, but there's also kind of no truth about how a particular class of system has to work or a particular set of problems, I mean, short of like physics, right, which we're still kind of learning, but probably have a good handle on. Seriously, be curious, dig into these things. Don't just assume that a thing falls in a particular category and it's not interesting, or it has to solve the thing in a particular way. You may discover a great technology that you can use. You may just learn something that you can apply to another project you're working on. You may find a great company to go work for. You may file it away, and a year from now, you're like, oh, I need to solve a problem. There was that thing I was looking at. But this is a really, really awesome time right now to be curious about database systems. there was the comment about Redis. I'm like, if anyone in this room has not gone and read the discussions about kind of how Redis is evolving right now, go read those. Because like whether you agree with them or not, whether you think that like the stuff is just like crazy insane or crazy exciting, it's really interesting to kind of see how that discussion is happening and kind of the different threads that are being pulled and the different trade-offs that are being discussed. And it's a really cool exercise in like how you should be thinking about systems going forward. And yeah, for sure, thank you for having us in your fabulous backlit room. It's my entire office fits almost in this space. So I know this is sweet. I'm definitely enjoying this. We're going to stick around here for a while.
Robert, takeaways?
Yeah, I mean, I would say have fun. You know, I mean, seriously, for the first time in a very long time, I think programming is really interesting. And you know, if databases are your thing, you think that's what you want to do, you got a couple of people up here that would love to talk to you. But I think that applying these technologies is every bit as interesting, possibly even more, depending on your interests. So yeah, so keep your head up and keep an open mind and have fun.
Okay, before we move on to Q&A, I just want to throw one more controversial question into this. If Oracle didn't exist or was it unavailable to you, what database would you personally use?
What problem?
Versant. Okay, Versant, okay. Something you're not so
my gut.
Great answer. Some of your work
The small talk version.
Is that your final answer?
I just can't, yeah, I mean, that's just too, it's like, what are your requirements? It goes back to everything we were talking about. You know, there's no one hammer. You know, we're done with that. This is, you know, from Oracle, right? I mean, sent within, but it's accepted. You know, there's no one hammer anymore. So look at your challenge, look at the requirements, and decide carefully.
Seth, NuoDB wasn't unavailable to you?
No, I mean that's right.
Pick the product by yourself.
There's no one. I don't think there's any one answer to that.
That's good answer. Let's take the first question. Yes.
Today, EU Commission ruled that people have the right for EAP. So would such events affect data gathering in a large?
Yes.
Significant way?
Yes. I mean, we don't. I mean, in terms of advertising, there certainly is a lot of discussion around that specific topic, being on track and being able to not be tracked, right? Is that right to be known, right to be proud? We'll see how this ruling affects.
Yeah, I mean, what's kind of wacky, right, is everyone's lost some amount of data in a database crash or a testing they've been doing and whatever, so we're all like, oh, you know, databases can fail, lose data. It's shockingly hard to actually intentionally forget data. Like, it ends up being like a really interesting, difficult problem. And I worked for a while when I was in research at Sun, kind of looking at different key management problems and different security problems. And so, yeah, I think that's, like I was having a conversation this morning with a financial institution here in New York, and one of the use cases we were talking about was the ability to kind of put data in known places and then encrypt it using different sets of keys so that you put different access policies. And we started kind of pulling on those threads and saying, you know, what are some of the things that you care about in different regions? These issues are becoming increasingly critical to everyone. And it's really interesting because everyone in the world has very different views on, you know, culturally, like views in Japan about privacy versus the EU versus the privacy versus what we have here in the US. You know, there is no one technology that addresses all of those concerns.
Even within the EU.
Right. So it's I think it's increasingly a really critical issue. It's going to be fun to see how people start kind of building around that in the next few years.
Well, there's also a lot of work that's going on in terms of anonymizing information, right? So now it's, you know, you've got a pretty good ability to make some direct correlation between data and the originator of that data. But I think that the bigger companies, you know, are threatened by that fact. And so they're working on ways to further anonymize information so that they can still do the kinds of things they want to do in the advertising space, but really have it decoupled from exactly who the source of that information is, right? And I just think we'll figure those things out over time. Some of it's legal, some of it's technology. These things will
Okay, before we go to the question, I do want to remind you all, we do have a Google Nexus 7 to give away. There is a basket moving around. Anyone know where the basket is? Someone hold it up if it's near you. There you go, all the way in the back. Okay, so please have that pass one more time around. I see some of you holding up cards to put in it, so just pass it around. We will be giving away this Google Nexus 7 at AppNexus. This Google Nexus 7 We will be giving away this Google Nexus 7 in AppNexus tonight. So just throw your card in there. If you do not have a card, you can write your information on anything and throw it in there. Just find a napkin or something, whatever you have handy, and someone will win it. Next question. Yes, right there.
Earlier it was mentioned that the AppNexus company, they handling up to a couple of millions transactions ingested in there, and at the same time you have a couple of petabytes of data in-house already. At the same time you're processing data and reading data. How do you handle the limitations of reading writes of hardware and the networking systems and stuff like this?
So the question is, I think, summarize it as given the inbound load of 1 to 2 million a second with fixed capacity, which is true, how do we handle dealing with this data flow every day? Yeah.
I mean, because every day it's, let's say not every day, every month the data ingestion is growing up. And you're, let's say 2 petabytes become 3 petabytes, 5 petabytes.
Yeah.
So you're seeing that you're, coming closer to your limitation that, and the, data is growing up. How do you extending it, and how do you managing it? It will not, face the bottlenecks that while you have to write a long response, because all the people they would love, using an internet, there's something popping out for them like in milliseconds and stuff like this, rather than waiting like time.
Yeah, we have an SLA of 100 milliseconds. We will get an answer back within 100 milliseconds, no matter what. That's the business. The way we do it is that, of course, the Hadoop and everything is decoupled from the entire operating marketplace, because you can never actually do Hadoop like that. Hadoop is really a store that stuff's written into and aggregates happen. We manage the size by just having a limitation on how much log level data is in Hadoop. It's 2, 3, 4 days sometimes, and that's it. We do adds on that, and then process on the aggregated results. We store log level data in 30 to 45 day archival storage in case of a disaster. But the honest truth is that we are constantly flushing that log into the data it's high.
And I'd be willing to bet you'd also say stay ahead of it. So, monitor it, get the statistics on it, and you can basically see when some of those SLA thresholds will be reached eventually. And so you can put processes in place to basically extend the systems a little bit. It's about process.
Okay. And one more question.
Wait, hang on. They will be here for one-on-one questions at the end, but we have to just balance the questions out. So pardon me. You will get your question just at the end of the session. For the next question, somebody else? Yes, right there.
Yeah, in the open source, we saw a couple of implemented more for the NoSQL databases, like Mongo, you also mentioned, CouchDB, and one more. So what should be a deciding factor that you have the problems of what deciding that should reach NoSQL to be for the purpose and the opinions, which
Robert, that was a NoSQL specific question.
Sure. So the question was, amongst the NoSQL technologies that are out there, many of them, most of them being open source, what really should drive your decision process in selecting one? I think in many respects it comes down to the type of data that you're managing. But it also comes down to the way you're using the data. So it is a difficult question to answer. If you're dealing with web applications and you're just naturally generating lots of JSON, then it would seem that a database that can store JSON really well for you is the right approach. That being said, there are a lot of people out there who are storing their JSON in key value storage because the access pattern is very simple. It's mostly a key that's looking at the data, or it's a secondary index into the key. And so it's not something, some sort of rich semantic that's going on involving all of the nested documents that would require a fairly complicated query. So, there's no hard and fast rule. Key value stores, if you're really trying to ingest data which fits into a fairly simple data model, it's a little bit more complex and it's naturally text oriented and it's XML JSON is one of those kind of databases. And if you're trying to solve a graph problem, you're worried about the relationships between the data and not so much the data itself. Then you're probably going to look for a graph database. So it just depends on your use case.
Okay, we have time for just one more question. Yes? Is that a hand up in the back? No. Okay, you can take your question.
Mike?
Yes. Sorry. All right, well, we'll skip that. Who's got the basket going around for the raffle prize for the Google Nexus 7? Everybody got their card in there, right? At the moment of truth. I'm going to ask you to mix it up. Absolutely, but you do have to look around in the other direction. You can't make your own. Look the other way. You pull it out, read it. Badiv Solomonic.